here we're looking at an actual question from the 2012 CAT exam. This is the day 1 version of the exam, and it's question 2dii, or 2d2. The length of a straight straw that will just fit into a cylindrical can with a height of 8 centimeters is given by the equation L is equal to the square root of 8 squared plus bracket 2r bracket squared, where r is the radius of the can. And they give a picture, looks better than mine, but they give a picture where you see the radius of the can and the straw that's fitting diagonally inside of it with a height of 8 centimeters. A straight straw that is 3 times as long, 3L, just fits in a larger can that has the same height. Write an expression for the radius of the larger can in terms of r in terms of the little r. So first thing might be helpful for you is to draw a diagram for what they're talking about. I often find it helpful. So it's a larger can with the same height, so what has to have changed? If it's the same height but it's larger, we need to have a bigger radius. And in this case, the radius is 3 times as large. Sorry, not the radius, but the length itself is 3 times as long. So we've got a longer radius. We can fit more in there. It's a big R, and going across here we have 3L and a height of 8. Same thing. So one of the things that they're hinting at here is that potentially we can use the similar sort of format to figure out what's going on here. And where this comes from is this is using Pythagoras, where we've got a squared and b squared, where the height 8 counts as one of the short sides, and r is only half of the bottom side here. To go all the way across, we need the diameter, which is 2r. So really, using Pythagoras, we've got 2r squared plus 8 squared is equal to L squared. So I could rewrite the blue equation, taking off the square root there. If I square both sides of that equation, I get L squared is equal to 8 squared plus 2 times r squared. And again, that's just using Pythagoras here for this right angle triangle, where we're using the diameter, which is 2r, the height of 8, and we get the diagonal there of L squared. So if I was going to write a similar expression for the right angle triangle here, we're going to get information to go with this. So here we go, writing it. We're going to have 3L squared, all squared, is going to be equal to r squared, sorry, not r squared, that's only halfway across, bracket 2r squared plus 8 squared. So again, that's Pythagoras. The long side, the hypotenuse squared, is equal to the short side squared plus the short side squared. So again, the diameter, 2r squared plus 8 squared, the height. Okay. So the aim of this problem, if you want to pick a point to focus on, is that they want an expression for r in terms of little r. So what they want is a big R equals a whole bunch of stuff, blah blah, with little r's in it. And right now we've got 2 equations. One has an L and a little r, and the other one has an L and a big R. And I know that I want just the little r and just the big R. So I'm going to use a trick here of substitution, where if I know that L squared is equal to 8 squared plus 2r squared, I can substitute that in to this equation if I have an L squared. So if I simplify out this first bracket here, I'm going to put the power onto both of those. So that's going to become 9L squared is equal to, go ahead and expand out this bracket while we're at it. So 2 to the power of 2 is 4r squared plus 64. And now I see that I've actually got an L squared in here. So what I'm going to do is take this L squared, which is equal to 8 squared plus bracket 2 little r squared, and I'm going to replace that where I see the L squared over here. So in fact, my equation is now going to be 9 bracket, exactly as I had it, 8 squared plus bracket 2r bracket squared bracket is now equal to 4 big R squared plus 64. So again, that's a straight substitution. I've got an expression that says L squared is equal to this thing, so I'm going to replace that L squared in the black equation over here with the L squared from the blue equation. Direct substitution. And now I'm on track, because if you notice, I've got a big R and little r all in one equation, which is going to help me get my answer of big R equals blah 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 with little r's inside of it. So now comes maybe the tricky part, maybe the easy part, not sure. I need to simplify out this equation. And remember, you don't have a calculator on this exam, which can make it a bit tricky in terms of our maths. So let's figure out where to go to from here. I might just keep this as expanding out the brackets. 9 times 8 squared. Or maybe I can say 9 times 64 plus 9 times, well, let's expand out these brackets as well. So 2 squared becomes 4, and the r becomes r squared, is now equal to 4 big R squared plus 64. Simplifying a little bit further, I'm going to leave that as 9 times 64 plus 9 times 4 becomes 36 little r squared is equal to 4 big R squared plus 64. So 9 times 64, you could times that out, but I'm going to use a little bit of a trick here to avoid having to do that maths. And I am going to think about this idea. If I have 9x on one side of the equation, let's say 9x on one side of an equation is equal to 3 plus x on the other side of the equation. If I subtract this x, because it's a plus x to the other side, I got 9x minus x is equal to 3x, or just equal to 3. And 9 minus 1x just becomes 8x is equal to 3. So I've combined like terms in a sense by rearranging those to the other side of the equation. I'm now going to do the same trick with these 64s. I have 1 64 on that side of the equation and 9 64s on this side of the equation. 9 times 64, just like my 9x over here. So I'm going to subtract that 64 to the other side, and if I subtract that 64 from the 9 times 64, I'm going to get, scroll down a little bit here, 8 times 64. So that's really 9 64s minus 1 64 simplifies to 8 64, just like I would have done here. Plus 36 r squared is equal to 4 big R squared. If you're wondering why I haven't times this out yet, you'll see my second trick that's coming up here. This 4 times r squared, I need to get r squared by itself. So if I undo the 4 times, I'm going to think, okay, what is that? That means I need to divide everything, all sides by 4. So if I divide everything by 4, I'm going to get r squared on this side, and I'm going to get 36 little r squared over 4 plus 8 times 64 divided by 4. And now to simplify these fractions, I have big R squared is equal to 36 divided by 4 is just 9 little r squared plus this big thing. Now if I ignore the 64 for a minute, because of my multiplication here, I can actually divide either the 64 by 4 or I can divide the 8 by 4. So if I go 8 divided by 4, I'm going to get 2 times 64. So in a sense, I'm just simplifying this part of the fraction. 8 divided by 4 is 2, and then 2 times 64. And 2 times 64 becomes 128, plus 9r squared is equal to big R squared. So we're nearly there. Last step of our equation would be that we need to get r squared by itself. So it's big R all by itself and not squared anymore. So big R equals a bunch of stuff with little r's in it. We're nearly there. So how do I undo a square again? That in fact is by taking a square root of both sides. If I take the square root of both sides, I'm left with big R is equal to the square root of 128 plus 9r little r squared. And that's my final answer. That's what they were looking for. An expression for r, big R for that big can, in terms of little r, which is what I have here. So if I knew what either of those values were, then I would be able to give you an answer. But this, in fact, is what they're looking for. Big R is equal to the square root of 128 plus 9 times little r squared.